Hello friends. So once again I am back. So with another lecture. So this time I will be discussing engineering surfaces. This lecture basically refers to the modification of the surfaces of various material. So in order to meet some of the properties. So it is a brief presentation, but quite informative. So let's start with this presentation. So let's see how this term is being defined. Engineering surfaces, or at times it is quoted as surface engineering also. So what exactly uh, is a surface? So we can say the bounding face of the bulk material that interacts with the surroundings. So that is commonly known as the surface of that material. Then comes the concept of engineering surfaces or surface engineering. So basically, this term refers to the influence of different process on the properties of the surface of that material. So the main objective here is to, as I told you, to modify the properties of that material. So we are not modifying the properties in bulk, but we are just modifying the properties of the surface of that material so that the desired purpose is served. So that is our main objective. So that way it is cost effective also. Instead of changing the whole material, the bulk material, we are just modifying or changing the properties of the surface. So as per some renowned researchers, they have given their own definition. So as per Bell, the surface engineering, as he defined, he said the application of traditional and innovative surface technologies to engineering components and materials with properties unattainable in either the base metal or surface material. So here he says we are going to apply some traditional or some innovative methods or the combination of those methods. So the objective here is to modify the properties of the materials which we cannot modify with other which we cannot get in other cases. So those properties we would try to enhance with the existing or the old or some newly proposed methods. Similarly, as per the ASM handbook, they defined the surface engineering. They said treatment of the surface and near surface regions of a material to allow the surface to perform functions that are distinct from those functions demanded from bulk of the material. So here we are demarcating the bulk material from the surface. We are focusing just onto the surface, that is all. So as an example, suppose I am having some material which is a low cost material which is having sufficient mechanical properties, but the application where I'm going to use that material, it involves friction and wear. So what I can do, I can just modify the surface properties of that material and using that application. So these are the two references of the two statements, Bell and ASM handbook. So let's move ahead. Now, I would like to discuss here some of the material properties, not in detail, but some basic properties, properties of the bulk material and properties of the surface of the material, just for the sake of understanding, so that students can get a clear understanding. Here, so we have bulk material properties, we have surface material properties. In bulk, we have strength, density, ductility. We can have more properties also. But just to show you, I have taken some few properties. And in surface, the properties of the material surface, we have hardness, friction, wear, corrosion, oxidation, etc. Just a brief discussion on these properties. Strength. Strength is of the whole material. Now, what is strength? That is the capacity of the material to withstand the applied load without undergoing any plastic failure. So this properties normally we study in strength of material also in that subject. So strength basically is not a surface property; it is the property of the bulk material because the whole material is going to resist against the applied load. Similarly, when you go to density, so density again is the property of the bulk material. We very well know the definition of density, that is the mass of the material per unit volume. That is called density. Now, just as an example, density uh, may affect the surface properties. So these are some of the basic properties, bulk material properties. We can categorize them as mechanical properties also. So then comes ductility. Now, ductility, very common feature, a very common characteristic of a material. So with this property, the material has the ability, we can say, the metal can be hammered into thin wires without without any breakage. So most of the metals are ductile materials. As an example, your copper is ductile, silver, gold, samarium. These are ductile materials. So opposite to ductility, we have brittleness also. So this is just to give an idea. So these are the properties of the bulk material, of the whole material. But when we talk about the surface properties, as I've taken a hardness. Now hardness is very much a surface property. So what is the hardness? It is the resistance offered by the material when some load is impinged upon that material, when there's some load is applied on that material. So it offers a resistance. Basically, it offers resistance to the plastic deformation caused by that impingement or caused by that indentation. So this is that is called hardness. So this is the property of the surface. So if you can recall, we have various hardness measuring equipments. You can say Rockwell hardness measuring equipment, Vickers hardness measure equipment, then Brinell hardness, Knoop hardness. So in all these testing equipments, we just indent the surface of the material. So why? Because this is the property of the surface. Similarly, we go to friction. So friction, as I have discussed in my first lecture, it is nothing but the opposing force, the force opposing the motion of the body. As an example, since all of us we know what is friction. If you have two surfaces, say this is one surface and this is the second surface. So none of the surface you will find purely smooth. So there are some irregularities. So this is a irregularity, this first surface, and this is your, say this is your second surface. So when these surfaces come in contact, so when they come in contact, sort of interlocking develops. You can see interlocking will develop. And once there is action from one side, so what will happen? All these asperities which are in contact, they will react back. And this is what we call as a friction force. So that's why we say it is opposing force. Force opposing the motion at that very contact. So that's called friction force. And this again is the surface properties, because when we talk about these irregularities, these are all on the surface. Now comes wear. Wear, we know, the progressive loss of material. As you can take the example of this interlocking. So what will happen? So these points where there are interlocks, sometimes they get cold welded. Just quote an example. So when action is applied by one surface, so that breakage is there. So means some of the material has been removed. So there are various causes for the removal of the material. So where is the progressive loss of material? So that is why various researchers, what they are doing, they are exploring the different types of wear mechanisms. So that again is a great field. So then come corrosion and oxidation. Corrosion, we know. So that is the removal of the material is caused due to electrochemical reactions. And oxidation, when your material is exposed to oxygen, so it will form some sort of oxides. For example, with aluminium, with iron, with copper, we have huge range of oxide formations. So these are all related to surface. So I hope the difference is clear. What are the material properties? What are the surface properties? because before we go for the tribology in detail, we should be aware of this. Let's move ahead. Now, some of the processes which have been used to enhance the surface properties. So those have been categorized as, we will discuss in these three categories. In these, we will take these three classifications. First is without chemical alteration of the material. We don't make any chemical change in the surface of the material, but yes, we do change the property metallurgically or by changing or the surface texture, some sort of. So that's first classification. Then comes your changing of the surface chemistry. Now we can change the chemistry of the surface by infusing some atoms or some molecules, by say making some chemical reactions, and then by adding a new material onto the surface. Altogether a new material, maybe a new composition onto the surface. So that is sort of coatings or claddings what normally are being done widely in the world. So we will discuss in brief these three processes just to have a clear understanding. So first one is without chemical alteration in the material. So under these categories, the commonly used processes. So this classification can be widened, but just for the sake of understanding, I have taken it in brief. So let's classify it into, first is thermal process. What are these thermal processes? As you see, laser based and flame based. Now, laser basically, we nowadays a lot of work has been done in the on the laser side. With laser, intense heating of the material is carried out. So it is much faster than the conventional methods. So high power beam is focused onto the material, and instant heating you can have in case of lasers. So while applying this laser to the material processing, we can further classify it. As an example, suppose if you want to change the microstructure of a small area of that surface. So that's one category. So there we can use limited energy of that laser to cause that change. But if you want to change the state whole, if you want to carry out some phase transformation for the large areas, so then we have to increase the amount of power involved. So likewise, it has been categorized. So with laser, we can is modify the properties of the surfaces. And on the same lines, we have flame hardening. It's a conventional method. Now, in this process, flame-based processes, normally known as flame hardening, we harden the surface of the material by processing the flame on that surface. So we create flames with the oxyfuel gases. Now, what are these oxyfuel gases? It involves the combination of oxygen and some sort of fuel gas. The fuel gas may be propylene or some natural gas or acetylene, propane, etc. So these flames are impinged onto the surface of the material, which is to be the properties of which are to be enhanced, and then the material is subjected to quenching. So it is a heat treatment process. So with this process, we can increase the hardness of the material. And moreover, the best part is that this is a cost-effective process as compared to other hardening process. Its cost is quite low. So these are the thermal-based processes where our focus is on the thermal aspect. Now on the other side, we have mechanical processes also. As I told you, we are not making any chemical alteration here. So in mechanical processes, we have some of the processes I have listed: short peening, short blasting, explosive hardening. Now, what is a short peening? Now, in case of short peening process, we take balls of hard materials like glass or some ceramic or some hard metal, and then these balls are impinged onto the surface, the properties of which are to be enhanced. So throwing of these balls onto that surface it induces compressive strength in the material. It will compress the surface of the material, and thus we get modified mechanical properties of the material. But the important thing is, while stacking those balls onto the surface, the stacking force should not be such so that it causes plastic deformation. So plastic deformation is not our objective here. We want to induce some compressive stresses so that the properties get modified. So that is what we do in short pinning process. In short blasting process, again, this is a as we're discussing, these are the surface treatment processes. So in short blasting, we what we do, we throw high velocity abrasives onto the surface. So with the high velocity abrasives, the surface is cleaned and is ready for the secondary operations. Now comes explosive hardening. Now this explosive hardening, this process, as the name itself clarifies, explosive hardening. We are hardening the material, we are increasing the hardness of the material by making use of explosives. Now in this process, the explosives are directly applied to the surface of the material, and then all the explosives are detonated. But they are directly detonated onto the surface. So what will happen after the detonation? We get some forces, and these forces are driven into the metal surface, and thus the hardness of that surface is increased. In this case, we can say the once the detonation takes place, the forces which we get from the explosives, they cause plastic deformation, and this plastic deformation results in the phase transformation, and thus we get increased hardness. So these are the processes which normally are being taken under this category, under this classification of without chemical alteration in the material. Now let's see, how can we change the surface chemistry? If you can change the chemistry of the surface, yes, properties can be enhanced. Now in this case, we have thermochemical diffusion processes. So from the name it is clear, we are diffusing something. We are diffusing something external. So in this processes, metal or non-metal or some other materials, their atoms are diffused into the material surface so that the microstructure is modified, and thus we are making chemical changes. So if the microstructure is modified by diffusing some of the external atoms, it is changing the chemistry of the surface. Yes, it is the selection of the diffusing atom is very important. It is done based upon the enhancement of the properties. It's under this category. Some of the processes which has been quoted: nitriding, carburizing, nitrocarburizing, boronizing, siliconizing. Similarly, you can have aluminizing. You can have other processes also. So nitriding, from the word, it's a nitride. So what we are doing here, in nitriding, we are diffusing the atoms of nitrogen onto the surface. Similar in carburizing, what we are doing, we are diffusing the atoms of carbon onto the surface. Now you can understand nitrocarburizing, atoms of nitrogen and carbon. Boronizing, atoms of boron are being diffused. Siliconizing, atoms of silicon are being diffused. So likewise, we have a huge range of these such similar processes. Now next we see chemical conversion coatings or chemical conversion processes. Oh, so this is the process which is carried out or which is developed using electrochemical or chemical reaction of metals, and thus forming a layer which consists of that metal, so you can say the metal compound. So that is how these type of methods are, the coatings from these type of methods are developed. So these methods are very economical. They're economical than the other processes, and and uh, they offer good protection against corrosion, and the materials which have been, the coatings which have been generated to these processes are ready for further processes also. With chemical conversion processes, the material uh, can you can have a material which is conductive. If you compare it with the other processes, as an example, if you take anodizing, you produce coatings with anodizing. So what you will get? You will get coatings which are not conductive. But with chemical conversion process, you can develop coatings which are conductive. Let's see classification. So I put two processes: chromating and phosphating. Again, the name itself clarifies. Chromating. Now you know what is a chromite, a material. Phosphate is a material. So again, in the chromating, you form an oxide layer of that material surface onto the metal. In phosphating, the phosphating again is a chemical process for the surface treatment. So here, soluble metal phosphate layers are developed on the base materials, and generally these layers are porous. And again, these layers are suitable for further treatments also. So likewise, we can have more list of processes under this chemical conversion coatings. Now, a very common process, electrochemical process. Again, it comes under the category of by changing surface chemistry. We know what are electrochemical processes. Now, I'm not discussing this in detail. In short, these are the processes which normally are being carried out to as a finishing operation. For example, we go for anodizing, as I was discussing. So anodizing of some metals, maybe of aluminium or other metals. So this prevents material from corrosion, from wear, and from all other effects. As an example, it prevents material from aging also. So this is the classification of processes under changing surface chemistry. So thirdly, we have by addition of a new material onto the surface. So in this case, you add a wholesome new material. It may be a new composite, new metal, new alloy onto the surface of the material as a coating. So as I was discussing, that we are not changing the bulk material, we are just changing the surface of the that material. Under this classification, we have coatings and as well coatings and claddings. So coatings, we have solution state, molten, or it may be semi-molten also. I have not mentioned here. Molten or semi-molten state, and then gaseous state. Now under solution state, we have these processes. Now solution, the solution, what is the solution? It is basically a homogeneous mixture of two or more materials. So that is normally referred as solution. So under this process, we use aqueous solutions, and deposit are developed on metallic or on non-metallic substrates also. So this solution method can also be categorized into chemical process, electrochemical process, as it is being listed. Sol gel process. Now there is a word which has been written here, sol gel. So this is solvents, this is a solution, and gel is the gelatin. So under this category, we have the sol gel process, chemical solution deposition. Then comes electrical deposition. So then comes molten state, molten or semi-molten state. So in this process, the material which is to be coated onto the bulk material substrate, bulk material surface, it is first brought to this molten or semi-molten state. We have thermal spraying, we have laser method, we have welding. Using these three, we can carry out the coatings. So just as an example, let's suppose I'm having mild steel. Now I want to use that some application where high tribological properties are required. So what I can do, I can develop a new composition, altogether a new composition, and that composition will be uh, will be used as a coating onto that mild steel. Now you can see that that composite is having superb wear and frictional properties. And in spite of developing a new bulk material, I am just using some of that new composition and providing coating to the mild steel. So that way, my work is done, my job is done, and it is quite cost effective also. Yes, we have to check the compatibilities of the substrate and that of the composition. Those are to be checked so that they adhere to that surface. That is important. And these three processes are being used widely now. Nowadays, people are using them widely. Lasers, the welding and thermal spraying. They are in most of the countries. People are developing coatings using these processes. Then comes gaseous state. Now, gaseous state in this under this classification, the coatings are whatever is to be coated. That material is to be passed through a gaseous or vapor phase before it is deposited onto the desired surface. So some of the common gaseous state processes are chemical vapor deposition, physical vapor deposition, ion beam gaseous depositions. So you can see here these terms which I have discussed here, the classifications, chemical solution deposition, sol gel, thermal spraying, laser, chemical vapor deposition, etc. These are not new terms. They were already there, existing. But now the researchers are making use of those techniques in modifying the properties of the surface of the materials. So the best combinations are sorted out, and that's why I have shown you here how these are being used. So this is all in this lecture. I hope you by this you have a just idea about the processes which normally are being carried out to change the properties of the surface of the material. Thank you very much for listening. Hope to see you again.